So our sense of hearing comes, of course, from our ears. So whenever a sound is happening outside, it's going to release vibrations in air, and those vibrations are going to travel down into our ear through our external acoustic meatus, and they're going to hit our tympanic membrane. So the tympanic membrane is our eardrum. Okay, so if any of you are in band, you know that a timpani is a type of drum. Those are the ones that are going boom, 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 boom. All right, those are going to start to vibrate just like a drum head. Okay, so they're going to start vibrating in the same frequency of the sound waves. Those sound waves are going to then pass through our auditory ossicles of the middle ear. So as that tympanic membrane is moving, it's going to cause movement in our auditory ossicles. So these three bones here are going to start vibrating. So now we have vibration of the bones at the same frequency of the sound from outside. The last one of these, the stapes, is going to touch what's called the oval window. When it touches the oval window, inside the oval window is going to be a fluid. Okay, this fluid can be found in a cavity called the scala vestibuli. Okay, so the oval window is pushing against that scala vestibuli. Well, what happens if you thump the side of a water bottle? Well, the wave that you make with your finger is going to then pass into the water, and you can then watch that wave move through the water. Well, the same thing is going to happen here because our scala vestibuli is going to be filled with fluid. So now that sound wave, or that stapes is pushing, and it's going to be making the same waves now in this fluid that was found outside. So now we're passing that wave into fluid, just like waves in the ocean. Okay, as we move through our cochlea here, those sound waves are going to then pass over or into or around our spiral organs. Okay, passing over our tectorial membranes. Now, these are then going to be vibrating, well, just like seaweed does in the ocean. So when a wave hits seaweed, it moves, right? So as the tectorial membrane is moving, it's also going to be moving little hairs on or in our inner and outer hair cells of what's called these spiral organs inside our cochlea. So these little hairs are now moving in the same frequency of those sound waves. Okay, so just like kelp would move in motion with the waves of the ocean, these hair cells are now moving in the same frequency as the waves in our scala vestibuli, which is from the waves outside. So now we have movements of the waves, and now we're moving those hairs. But what do we know about hairs? Well, that these little hairs are, of course, connected to incredibly sensitive nerves. When these hairs move, they will then send a signal out to the nerve that will go through the cochlear branch of our vestibulocochlear nerve into our brain, that your brain will then collect all of the information from both ears and say, this is what I hear. Okay, so it's from pressure waves outside causing movements of bones, causing little tiny physical waves and fluid in the inner ear. And those waves bump up against the hair cells, moving it just like kelp in the ocean. And whenever it moves, it will send the signal to say, hey, I am moving, and I am moving in this frequency. And that is how we hear.